Hello and welcome to the presentation of Automated Planning Simulation with PDSim. My name is Emanuele de Pellegrin and I'm a first year PhD student at the Robotics University and the Edinburgh Centre for Robotics, and my PhD is on robotics and autonomous system, and I'm working with Professor Ronald Petrick. So PDSim stands for Planning Domain Simulation and is a plugin for the Unity game engine that extend the functionality of the game engine, helping the user simulating an automatic planning plan. So in this talk we'll look into why we need to simulate a planning problem and a brief history of why I come up with PDSim. What are the main features of PDSim as well as the new features, and which are the building blocks to set up a new simulation, and the further updates we have in mind for the future of PDSim. So why we want to simulate a plan in the first place? This is a question I wanted to answer during my Master in Science and AI at the Yearovat 1 year ago, and mainly because I wanted to help new students approaching PDDL for the first time. And for example, here we have an example of a plan in the blocks word domain, and we have different sequence of action in order to solve the problem. And PDSim basically takes this input and translate in a more visual Q examples, working in a 3D world with 3D animations. For example, the blocks B, A, C, and D are represented by cubes in these scenarios, and also we have the table for animating the predicates on table, which is in the blocks word domain, and also we have the hand represented by a simple sphere, and this can be a bit easier to approach for people who are not experienced in planning in general, but also can help a researcher to rapidly prototyping a new domain and problems, and in checking on the fly if there are errors inside the domain definitions. So let's look at the new features of PDSim. We now use a new parser, which is well supported by the planning community, which is Tarski, and we also implemented a new Python backend which can communicate with the Unity frontend and is mainly responsible for calling the parser, the Tarski parser, and provide a JSON file which contains all the domain specification, and we can parse in Unity and create objects inside Unity, but also you can connect with ROS and you can use your own planner. For example, there are experiments working with fast downward. We also created a new and intuitive animation workflow. We are not using any more scripting. We are not requiring the user to know C#, which is the main language of Unity, but the user now can basically create an animation using a graph-based workflow. So what are the main actors here in PDSim? What are the simulation building blocks we need in order to run a new simulation? When we first start a new Unity project and we plug in PDSim, we are asked to define our own domain and problem file when we're creating a new simulation, and PDSim automatically creates this simulation manager, which is the main component for all the simulation. It handles type checking of the domain file. It creates the instance data, for example, all the actions encoded inside Unity from the domain file. It holds copy of PDDL objects blueprints, which are called simulation objects, and it handles all the animation during planning time. So this is the main UI of the simulation manager. We have the problem instances. We can have several problems for one domain, and for example here the logistic is just the problem 4.0, but we can define different instances to test our domain and simulate. Then we have the animations, and the animation are basically the predicates which are going to be animated, and we also have these type 3 that are used for type checking, and the leaf nodes, or the objects inside the problem file, are highlighted in blue here, and these are the simulation object or problem object that the user can customize with custom models, shaders, or whatever the user wants. So what are simulation objects? They define the appearances of the object using models, 3D models or 2D models, whatever, and materials or shaders, and the user can define the model's points of interest, let's call. Here we have the example for the truck in the logistic domain. We are basically dragging in the model inside the Unity interface, and the user of course can define control points or point of interest, as I called before. For example, we are defining here the front of the truck and the cargo point of the truck. These points are used during animation time. For example, I want the package to be animated and go inside the cargo we are defining here right now, and they are mainly used for animations. So the animations are defined for each predicate, and they are using a graph-based system. So we have a different similar tool to PDSim that are available online, but PDSim is different because as a new additional definition language for animation are not required, because we worked in order to solve this problem and have a more high-level language, or let's say a high-level representation of the animations. So we don't want the user to learn another language to just define the animation. We want the user to have this simpler user interface with node systems where he can draw the connection between the nodes. For example, here we are animating the in predicate for a vehicle, and we want of course an animation sequence. Then we just want the move to object animation because we want to move the package inside the truck, and we specify the control point we defined earlier as the cargo. So we want to move the package inside the cargo. We can have concurrent animation. For example, when the package ends its own movement, it changes the color to red. And finally, we have the user interface that is used for displaying planning time information to the user, or displaying object states when the user hovers the mouse on the object inside the scene, and used base for navigation between instances of domains. In particular, we have this highlights the current instance we are simulating, and we can go back to other simulation and loads other simulations. This highlights the object states that are explored during planning time, and here we have the plan and all the actions we are left for finishing the simulation. And finally, this will be part of the temporal planning update, where the user can display the total time of the simulation, as well as the action timer for each action executing concurrently in a temporal planning problem. What we have in mind for future updates, we want to fully support temporal planning inside PDSim. We want deep integration with ROS and ROSplan, a new way to visualize epistemic belief. Then we want robust animation creation. So now we have the parsing system for the graph. It's really simple but effective, but we want for the user more granularity and new ways of defining custom animations. Last but not least, we want to open up the source code for all the planning community. Thank you very much for your time. Bye.